What is going on YouTube? It's Darian. I'm back here with Darian the Dev, and today we're going to talk about solid principles in programming. The solid principles. So S.O.L.I.D, solid principles in programming. If you guys are boot campers or if you're very new to programming, I highly suggest you guys go look up the solid principles and get super familiar with them if you're looking at going into professional software development. So what is SOLID? So SOLID stands for single responsibility principle, open close principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. I'm just gonna give you guys a quick overview in my own words, terms, what the solid principles actually are, what they mean, and then you guys can kind of take that and go do some more research on your own and kind of get a more, drill down, deeper understanding of each principle itself. All right, so starting out with the single responsibility principle. So that is one of the more self-explanatory ones, right? So single responsibility principle basically just means that everything that you guys write in your code at work or just in general, especially like methods in classes, they should each serve a single responsibility. So whenever you make a method, you should never try to solve more than one thing with a particular method. Having one method that does more than one thing becomes way too problematic down the road, especially if someone else needs to maintain your code. You definitely want to make sure that everything is very readable, very self-explanatory as much as possible, and that you don't have, a huge function or method that's running hundreds of lines long. I've heard of actual methods that are like thousands of lines of code long. So the point is to basically just avoid that, and every piece of code you write has its own single responsibility, and that also rolls over into things like SQL tables. So if you're doing database stuff, each table should have its own reason for existing, its own responsibility for existing, and you shouldn't try to store too much information in one table as opposed to breaking up that table into multiple tables that have their own responsibility for each one. So single responsibility principle is super huge. It keeps being brought up, and I think that is something that's very, very worth learning about. So go check that one out. The second principle of solid is going to be the open close principle. And the open close principle basically means that all the methods that you write or create should all be open for extension but closed for changes or closed for modification when it comes to the base functionality of the method. This kind of ties into encapsulation for everybody who's familiar with the 4 principles of OOP, which I will go over in another video. Encapsulation is a part of the open close principle because base functionality, you want to make sure that that's limited to other developers or users should not be able to change the core functionality of a method, whether that's intentionally or unintentionally. They should be able to extend or build on top of methods that you've already created, but they shouldn't be able to change the core functionality of that method. So the open close principle, again, the method should be open for extension or to be built upon or have things added to the method. However, the original base functionality should not be able to be changed. The next one in our solid principle is going to be the Liskov substitution principle. This one I'm still a little bit fuzzy on. That one I'll just encourage you guys to go look up. Again, it's called the Liskov substitution principle, and I would go read that one and look for some actual code examples because I would really be doing you guys an injustice if I tried to explain it to you. My understanding is just too limited to explain that one in like a clean, concise way. So I'm gonna stay away from that one, all right? The next one is the interface segregation principle. And pretty much this kind of ties back to the single responsibility principle in a way, in the sense that each of your interfaces should handle a specific responsibility and they shouldn't cross over with other interfaces. So, it's better to have tons of smaller interfaces than huge, gigantic, big interfaces, and only have, a few of them that a bunch of things within your program actually inherit from or implement, because it's not going to need all the methods that are created inside the interface. And if it doesn't need it, then it leaves a lot of room for error if something implements something that it doesn't need all those methods from. So it's better to have tons of hierarchical interfaces than it is to cram everything into a few interfaces and make everything in your program implement those interfaces. So again, it's better to break that down into a bunch of small interfaces and have each class implement multiple interfaces than it is to have just a handful of huge interfaces that are full of all this different functionality that may or may not get used or be necessary for a particular object. And the last one is the dependency inversion principle. So again, the dependency inversion principle kind of ties back into abstraction and the single responsibility principle, in the sense that when you write code of things that inherit from other classes or whatever your case is, those things should be very loosely coupled, meaning that they should be able to extend and derive new classes without being tightly coupled to the parent class. And so again, I'm gonna leave that in the description. I'm gonna leave resources in the description down below for you guys to go look more into these things. I would encourage you to go find actual examples. I just wanted to make you guys familiar with the S.O.L.I.D principles and give you some exposure to what they are. If you guys haven't been exposed to it, if you're in boot camp or anything, I'm sure it's something that'll come up at your first job or possibly in job interviews or on applications. So I just really want to get that information out there, you guys. If you have any tips or comments or feedback for me, please leave it down in the comment section below. Again, I'll leave as many resources as I can down in the description for you guys to go check this stuff out and go learn and look up examples of these things actually in code and how they look being implemented. But again, if this helps you guys at all, please leave me a like, share, subscribe. It helps me a ton with just motivation to keep making videos for you guys. And I've got more content on the way, so I'm gonna get to making the next video. But I'll see you guys in the next one, all right?